So today we're going to be talking about component 2, which is all about arithmetic sequences. So an arithmetic sequence is when the difference between successive terms is always the same number. Then we call this an arithmetic sequence. So for example, if we had 1 and then 4, 7, 10, 13, what's happening is I'm adding. The difference between these is the same each time, right? So this would be considered an arithmetic sequence because I'm adding the same amount or subtracting the same amount each time. Now, an arithmetic sequence can be defined recursively or explicitly, or sometimes we call it the nth term. So recursively, we find the formula and we say, well, this is our first number. And then our second number comes from finding the number before it and adding that common difference. So in this example, right, our first number is 1. So we would say a sub 1 is 1. Then you find the next term by doing the 1 before it plus our common difference, which in this case is 3. Okay, so this is our recursive formula for this equation, right? So what this means is, let's say I wanted to find the third term, so a sub 3. I would go to a sub 3 minus 1, which would be a sub 2, which in this case would be 4, and I would add 3. That's what this is saying. Okay, now the nth term will tell us any term. If I use this one, I have to know the one before it in order to find the next one. The nth term will tell you any term. So our nth term formula is saying I want to find any term. I'm going to take my first term, which in this case is 1, my common difference, which in this case is 3, and minus 1. So this formula that we just wrote, this equation, is going to tell us any number here, right? So this is our first term, our second term, our third term, all the way until it ends, or maybe it doesn't end. So if I wanted to find, let's say, maybe the 10th term, that would be a sub 10. So what we would do is we would plug a 10 in here, find our answer, and that would be whatever is in that 10th spot. Okay, so kind of just talking, so let's do some examples. So the first couple examples here wants us to determine whether the following are arithmetic. If so, write the sequence recursively and as the nth term, which would be explicitly. So if I want to know if this is an arithmetic sequence, we have to see to make sure that we're adding or subtracting the same thing each time. So in this problem, we are adding 2, adding 2, adding 2. So this would be an arithmetic sequence. Okay, because it's arithmetic, it wants us to write the sequence recursively. So if I want to write the sequence recursively, I need to figure out, well, what is our first term? Well, our first term is 4. What is our common difference? Well, our common difference is 2 because I'm adding 2 each time. So recursively, we write a1 is 4. Our nth term is going to come by taking the term before it and adding 2. So that's our recursive formula. Now our nth term formula, we're going to use this formula here. So we say our nth term is going to come from taking our first term plus our common difference and multiplying by n minus 1. So for example, if it said find the 11th term, we would say, well, a sub 11 is going to be 4 plus 2 times 11 minus 1, which would be 4 plus 2 times 10, which would give us 24. So if I went all the way to the 11th spot in our list, that number is going to be 24. Okay, so now in number 1, it was pretty easy to tell that this was arithmetic. Now if I gave you an equation, it's a little harder to tell what are we adding each time. So we're going to have to kind of prove that this is an arithmetic sequence by looking at our consecutive terms. So we're going to say, well, our first term is 3n plus 5. Now the next term after that would be n plus 1, the next term. So that's going to be 3 times n plus 1 plus 5. Distribute. Okay, now to check if this is arithmetic, we're going to say, well, if I subtract 10 minus 8, I get 2. 8 minus 6, I get 2. 6 minus 4, I get 2, right? All of these are 2. So we're going to subtract here and see what we get. So I'm going to take the n plus 1, which is 3n plus 8, and I'm going to subtract the one before it, which was 3n plus 5. Now if I distribute that negative, I get 3n plus 8 minus 3n minus 5. Well, the 3n and the 3n cancel, and I'm left with 8 minus 5, which gives me 3. Now, because this is just a constant, it's just a number, that does mean that it's arithmetic. So it is arithmetic because I just got a constant here. If I would have gotten like n minus 2 or something, then it would not be arithmetic. So that's also what our common difference is. So our common difference is 3. So a sub 1, well, in order to figure out a sub 1, I need to plug 1 in for m. So a sub 1 is going to be 3 times 1 plus 5, which gives me 8. So the first term in the sequence is 8. Our nth term comes from taking the one before it and adding 3. That's our recursive formula. Now our nth term formula says a sub n is equal to the first term plus the common difference n minus 1. So I would like you guys to try example 3 on your own and check the answer on the answer key. Okay, so number 4, we're no longer trying to say, is this arithmetic or not? I'm saying it is an arithmetic sequence. I want you to find the 41st term, right? So I know A1, A2, A sub 3, A sub 4. I want to know if I went all the way to A sub 41, what would that number be? That's what I'm trying to figure out. Well, it's really easy to figure that out if we use our nth term formula. So remember, our nth term formula is a sub n is equal to a sub 1, which in this case is 2, plus the common difference, which in this case we're adding 4 each time. So our common difference is 4, n minus 1. Now that I have my nth term formula, I can plug in our 41. So a sub 41 is equal to 2 plus 4 times 41 minus 1. So 2 times 4, or 2 plus 4 times 40 would give us, what, 160 plus 2 is 162. So the 41st term in the sequence is 162. Okay, now number 5 is going to get a little bit more complicated. So this one is asking us to find the first term, the common difference, the recursive formula, and the nth term formula. However, they're not just going to say this is the first term, this is the common difference, write it. They're going to kind of give you just pieces of it. So it's telling us that the 8th term of the arithmetic sequence is 75. So if I went to the 8th spot in my sequence, that is 75. And if I went to the 20th term of the sequence, that is 39. So if I need to find what am I adding and subtracting each time and where did it start? Okay, well, if at the 8th term I'm at 75 and by the 20th term I'm at 39, our common difference is going to be negative. We're going to be subtracting because I'm going from 75 to 39, so that means I'm subtracting each time. But what am I subtracting by? That's the question. So what we're going to do is we're going to use our nth term formula here to kind of figure that out. So if I wanted to find the 8th term, I would take my first term, which I don't know, a sub 1, plus the common difference, which I don't know, times 8 minus 1, which is 7. So times 7. So if I want to find the 8th term, I have to take our first term and I have to add 7, or add something 7 times to go from 1 to 8. Okay, now if I did the same thing for 20, a sub 20 would be a sub 1, plus I would have to add 19 times to get from 1 to 20. However, this isn't going to really help us. So we're going to say, well, I'm not going to use that because that's not very helpful. But what I am going to do is I'm going to use the 8th term because I know that. I don't know this. So how many times would I have to add to go from 8 to 20? Well, I would have to add 12 times to go from 8 to 20. Okay, well, what do I know? I know the 20th term is 39, so can't I replace this with 39? I know the 8th term is 75. Oh look, I just created a one-step or a two-step algebraic equation. Subtract 75. Get d by itself. Our common difference is -3. So that means I'm subtracting 3 each time. Now that I know our common difference is -3, now I can take that answer and plug it in here. Well, once again, what do I know? I know the 8th term is 75. I still don't know a sub 1. And I know my common difference is -3. Oh, look it, I just created another two-step algebra equation here. Multiply, we get -21. Move that to the other side by adding. We get 96 is a sub 1. So my first term is 96. My common difference is -3. When I subtract 3 7 times, I get to 75. If I subtract 3 12 more times, I get to 39. So the first problem wanted us to find, part A, wanted us to find a sub 1, and it wanted us to find our common difference. So a sub 1 is 96, and our common difference is -3. Okay, B wants us to write this as a recursive formula. So remember, our recursive formula says, well, a sub 1 is 96. To find a sub n, we're going to use the term before it and subtract 3 each time. Okay, now our nth term formula. To find our nth term, we have our starting point, 96. Now I'm adding the common difference, but in this case it's -3, so we're subtracting 3 each time, times n minus 1. Okay, keep in mind, Math Excel might want you to distribute this out and combine like terms. So it might ask you to do that. So that would be 96 minus 3n plus 3, which would give us a final answer of 99 minus 3n. Just as a heads up, I would be perfectly fine accepting this or this, but Math Excel probably wants you to continue to simplify. Okay, so now let's talk about the sums of arithmetic sequences. So instead of having a comma between each of them, we're adding these up. So I want to add all of these together and see what answer I get. But I'm not just going to sit here and type that into my calculator because, one, I don't know what all these numbers are. And that could be, we could be adding 1,000 terms. We don't really want to have to do that. So there is a formula here. To find the sum of our arithmetic sequence. Okay, so I'm going to first start by doing, I guess we should just do this example. So in this example, the 3n plus 5, we want to find the sum of what this would be, okay? But we don't know when it's stopping, when it's ending. So we're going to go through and we're going to find what the equation for the sum would be. Now, n is the number of terms, a sub 1 is our first term, and then a sub n is our last term. So over here, I know n is just going to remain n. A sub 1 I don't know, so let's start by finding A sub 1. So A sub 1 would be 3 times 1 plus 5, which would give me 8. And then A sub n is this guy right here. So our sum formula is going to be n divided by 2 times our first term, which is 8, plus A sub n, which is 3n plus 5. Let's simplify that a little bit. We get n over 2 equals 3n plus 13. So this is our sum formula for this arithmetic sequence. Okay, so the problem didn't ask this, but so that you understand what this is saying. If I said find the sum of the first 10 numbers, okay, so the first number is 8. The second number would be 11, right? The third number is whatever. I want to know if I added up the first 10 in my calculator, what would I get? Well, I can just use this formula. So that means n is 10. So I could say, well, 10 divided by 2 times 3 times 10 plus 13. Figure that out. So that's 5 times 30 plus 13 would be 43. 5 times 43 equals 215. So if I added up the first 10 terms of this sequence, I would get 215. That's what this is telling us. Okay, so this was very generic, right? This is a formula that would work for any number. I could make this 1 million and I could figure out what it is. Now, in this problem, I have a start, I have an end, right? So I need to figure out what each of these are. And I don't really need to know what numbers these are because I can just use my sum formula. So what do we need to know? Well, we need to know what n is, and we need to know what a sub 1 is, and we need to know what a sub n is. So let's figure out what do we know. Well, our first value is 60, so a sub 1 is 60. Our final value is 120, so that's a sub n. But n is how many times did we get to there, right? So this is the first term, this is the second term, this is the third term, this is the fourth term. I need to know what term is this. Is this the 10th term? Is it the 12th term? I need to know that. So we're going to have to use our nth term formula to figure that out. So a sub n is equal to our first term, 60, plus our common difference, which in this case is 4, times n minus 1. Okay, well, a sub n is 20, so 120 I should say. 120 equals 60 plus 4 times n minus 1. Solve for n. So we just figured out that this term here is 16. It's the 16th term. To get from 60 to 120 by adding 4 each time, it's going to take 16 times. So now let's find the sum. So I'm going to find the sum of the first 16 terms. So our formula says to say 16 divided by 2 times a sub 1 plus a sub n, which is 120. And figure out what that answer is. So 8 times 180 gives us 1,440. So if I added all of these up in my calculator from 1 all the way to 16, I would get 1,440. Okay, so in this problem, same concept. Find the sum of the first 46 terms of the sequence. So a sub 1 is 2. A sub n, well, I don't know what the last term is, but I do know that I'm going to stop at 46. That's when I'm going to stop. I only want the first 46 terms. So I need to know what is a sub n, which is really a sub 46, because that's when we're going to stop. These are the same thing. So I need to use my formula to figure that out. So a sub 46 is going to be found by taking our first term, which is 2, plus our common difference, which we're subtracting 3 each time, times n minus 1. So 2 minus 3 times 45 gives us negative 133. So our 146th term is negative 133. Now we can find the sum of the first 46 terms. So n, 46, divided by 2, times our first term plus our last term. Find out what that answer is. Negative 3013. All right, almost done. We've got 2 word problems and then we're done. So the first problem here says find x so that these 3 terms are consecutive terms of an arithmetic sequence. So if my first term is 5x, my second term is 2x minus 3, and my third term is 4x plus 3, I want these to be an arithmetic sequence. If I want them to be an arithmetic sequence, then I have to be adding or subtracting the same thing each time, which means when I take this term minus this term, that has to be, let's say, 5, and when I take this term minus this term, that also has to be 5. So I need to be able to take 2x minus 3 and subtract 5x, and I need that to be equal to 4 plus 3x subtract 2x minus 3. When I subtract this, I need that to be equal to when I subtract this. Okay, now just use your algebra skills to solve. I'm going to pause and solve it. You pause and solve it as well. All right, so now that we found x is negative 5 over 2, now we can answer the rest of the question. It wants us to list the terms of the sequence. So I want to know what each of these are, so I'm going to plug in my x. So the first term is going to be 5 times the x, which is negative 5 over 2, which would be negative 25 over 2. The second term in the sequence would be 2 times x minus 3, which would be negative 5 minus 3, negative 8. The third term in the sequence is 4 plus 3 times negative 5 over 2, which ends up being negative 7 over 2. So those are our first 3 terms in the sequence. Now it wants us to write the recursive formula. So the recursive formula will say a sub 1 is our first term, negative 25 over 2. A sub n is the term before it, plus the common difference. So we have to figure out what's happening to go from each of these. And it ends up being plus 9 over 2 is our common difference. Then it wants us to write the nth term formula, which says we're going to take our first term plus our common difference times n minus 1. Lastly, we're going to go back to finding the 27th term, so I'm going to plug in 27 in for n. Which, when we plug that into our calculator, we end up getting 104.5. All right, one last problem. So number 10 says a ceramic tile floor is designed in the shape of a trapezoid, which is 20 feet wide at the base and 10 feet wide at the top. So the bottom here is 20, the top is 10. Each tile measures 12 inches by 12 inches, which isn't 12 inches by 12 inches, 1 foot by 1 foot, are to be placed so that each consecutive row contains 1 fewer than the preceding row. How many tiles will be required? So If I know this is 20 feet wide, and each of these are a foot wide, then that means that I have 20 in this row. Okay, then in this row I have one less. I'm at 19 tiles in this row, all the way up to when we stop, which is 10 tiles in the top row. Well, how many rows would we have? Well, that means that we have 11 rows. Now, if I want to know how many tiles we need, then that means I need to add them all up, right? Which means I need to use my sum formula. Well, how many rows do we have? We have 11 rows, so that would be n equals 11. Our first term is 20. Our last term is 10. So 11 over 2 times 30 is going to give us 165 tiles.